Okay, greetings and salutations. Now in this first part, I want all the notes taken. There's no problems on your own. So you're going to take this sheet and quietly rip it off so you can look at it, okay? So you got these two things. And your job is to factor the expression. Now there's either two terms or three terms. This one has two. So again, my job is to come up with two things that can multiply to this expression here. Very similar to taking like the number 20 and it'd be 4 times 5, but this is more of a complex expression. So there's two terms, so I do GCF and see if I have a difference of perfect squares. Okay, GCF 4 and 32. They're both in the fourth row. Okay, so we put 4. Now we do need an x because they both have x, and we also need it to be negative because the number in the front is a negative. So negative 4x. Factor that out. And then I go up and divide by negative 4x. So negative 4 divided by negative 4 is 1. X the second divided by x is x. 32 divided by negative 4 is negative 8, so minus 8, okay? And again, we don't divide those. Now, look in your parentheses. Is your x even to the second power anymore? It's not, so don't worry about doing a difference of perfect squares, okay? Okay, so then you're done. In the first parentheses, you put negative 4x, and then in the other one, you put 1x minus 8. Okay, my next problem. I'll explain what that's for here in a second. You have two terms, so GCF, same as up here, GCF, and then we see if we have a difference of perfect squares. Okay, now 6 and 2/16 is kind of tough because how would you know? Because the chart cuts off here. So what you're going to do is go to this little box I've made for you here and find, working from the bottom up, find all the rows that have 6. Well, it's in the 6th row. It's also in the 3rd row. It's in the 2nd row. And any number eventually appears in the 1st row. Now take your calculator and do divisibility test. See if the larger number divides by 6 first. If it doesn't, we'll try 3. So 2/16 divided by 6, it does. There's no decimal. So my greatest common factor is 6. It doesn't get an x, but it does get a negative sign because the very first number is negative. So I factor out negative 6. Now, negative 6 divided by negative 6 is going to be 1, okay? X to the second stays there because you're not dividing by x. You're just dividing by the 6. Then I take positive 2/16 divided by negative 6, and that's negative 36. Now, don't write plus negative, write minus. And here's another thing you're going to want to do. If you have a 1 in front of your x, get rid of it, okay? As long as it's a 1. Now, you do have x to the second, okay? So that's x times x. And we got the minus sign. And then 36 is also a perfect square. If you look on the board, it says the square root of 36 is 6. So that's 6 by 6. Okay, so we come down here. We go x, x, 6, 6. So in these parentheses, I put x plus 6, x minus 6. But don't forget to put that negative 6 in front of the parentheses. Okay? Because again, negative 6, after that's done, then this turns into this. But we can't forget there's still a negative 6 outside. Okay, this time how many terms we have? We have 3. So now it's the greatest common factor and then the table. Okay, so 3, 27, and 42. Here's 3. Here's 27, here's 42, so those are all in the third row. Now it doesn't have an x because in this number here is empty of an x. Also, it's not going to be a negative because we don't have a negative in the front. So it's just a 3. And then I divide. That's going to be a 1x to the second. That's going to be a plus 9x, and that's going to be a plus 14. Now when I do my t, my ABC, this is my new ABC, okay? So I take positive 1 times positive 14. Well, that's a positive 14, so the signs have to be the same. We'll start with them both as negative. Now I need to add to try to get positive 9. Divide by 1, you get 14. That adds to negative 15, so that's over the 9. Divide by 2. 14 divided by 2 is 7. Now, I'm going to add these because it's the right number, but it's the wrong sign. So I just now switch them both. Okay, now after you're done with that, you got to pay attention to what the A equals. The A up there is a 1. Okay, if it's a 1, we can get rid of it, and I just need 2 parentheses. I just go x to the second, that'd be x, and then plus 2 plus 7. So my 2 parentheses are going to have the x plus 2 and the x plus 7. Now don't forget that 3 is still part of the factoring, okay? It's right there. All right, next one. We got 9x to the second minus 30x minus 24. So that's 3 terms. So I do GCF. Again, you're going to have to start looking for GCFs on the 3 terms starting now. Okay, 9, 30, and 24. I think I can find those all in the third row. Okay, so 3. No, you're not going to use x, and you're not going to use a negative, so I factor out a 3. So that's going to be 3x to the second minus 10x. Now I'm dividing minus 8. And now I do the ABC from here. So I take positive 3 times negative 8. That's negative 24. So I got negative 24. So that's a positive times a negative this time. And we're trying to add the factors to get to negative 10. Okay, so I divide by 1. That would be 24. But I add those, that's negative 23. That's not close. I divide by 2, you get 12. 2 plus negative 12 is negative 10. So we got it. Now what is your A equal? This time it's not a 1, it's a 3. Okay? So if I expect to get the right factors in here, and A is a 3, we're going to make 4 parentheses total, and we're going to lead off with 3. And then I can go x plus 2, x minus 12. Now we know inherently that this isn't correct, because 3x times 3x is 9x a second, and I have a 3x second. So I look up 3 and 2, okay? Those are in the first row, so you can divide them by 1, but they just stay the same. So you have your first factor. Now the other one, 3 and 12, are both in the third row. So we divide by 3, and that's going to be 1x minus 4. Okay, now don't forget your GCF of 3. That comes over here. 3 times 3x plus 2 times 1x minus 4. Okay, we're going to go over another round. That's a 5 up there I put there. Okay, so now you're back to 2 terms. So that's greatest common factor. And then seeing if we have a difference of perfect squares. Okay, 5 and 125, okay? Well, again, I'm never going to know because this doesn't run all the way there. So again, I want to take 5 because that's the smaller of the 2, and it's in the 5th row and the 1st row. 5, 1. Now I'm going to try to divide the larger number by 5. 125 divided by 5 would be the first number. That works. So that makes 5 my greatest common factor. It's not going to have an x, it is going to be negative though. So I factor out negative 5. That's going to be 1x to the second. And then 125 divided by negative 5 is negative 25. Please write minus 25 then. Remember, we want to get the two parentheses. Now, when doing the dots, I would recommend you get rid of the 1, okay? If you have that in front of the x to the second. If it's any other number, you got to roll with it, okay? But the 1, don't need it, because that would be x times x. The minus is there. And 25 is up on the board. It says the square root of 25 is 5, hence 25 can be written as 5 times 5. So you have x, 5, 5. It's got to be like that. So x plus 5, x minus 5. Okay, now your greatest common factor, negative 5, has to be placed outside of it. Okay, and that's your factoring. Okay, next one, I got 10x to the second plus 40x. Okay, 2 terms, so that would be greatest common factor. And then we're going to see if we have a difference of perfect squares. Might not. Okay, 10 and 40, those are both obviously in 10's row. So the 10, and we are going to need an x, we don't need a negative, so we put 10x out there. So 10 divided by 10 is 1x, 40 divided by 10 is 4, and no x on that. Remember, when I'm dividing by x, the last ones cancel. Now, when doing adopts, you can get rid of that. My x is not even to the second power, so it cannot be adopts. Okay, so in your two parentheses, what you do in the first one, you're just going to put your 10x. In the other one, you put your x plus 4. 10x times x plus 4. Okay, 4x to the second power minus 8x minus 60, so that's 3 terms. Greatest common factor, and then my t-table. Okay, 4, 8, and 60. Well, here's 4, here's 8, and later on I see 60, so that tells me the 4 is my GCF. I'm not going to put an x with it or a negative. We just factor out the number 4. Okay, so it's going to be 1x to the second minus 2x minus 15. And then when I do my ABC, it's from the new parentheses, not from up here anymore. Okay, so I take 1 times negative 15. That's a negative 15. So it would be positive times negative. And we're trying to add to get to negative 2. 1 and 15, no. Okay, if I divide 15 by 2, it's a decimal, so I get rid of that, and then 3. 15 divided by 3 is 5. So now I add 3 plus negative 5 is negative 2. Okay, great, you found it. Now you got to decide how you're going to set up your parentheses. Remember, I need 2 parentheses at the end. Now my a up there is just a 1, so we can get rid of the 1 and just write x plus 3, x minus 5. So x plus 3, x minus 5. Now the 4, factor that out. Okay, so you got 4 times x plus 3 times x minus 5. Those are times dots I'm putting. Okay, last one. Okay, GCF and table. Okay, now look at the 6, 17, and 5. Well, here's the first time 5's there, but I'm not seeing 6 or 17. Okay, no 5, no 5, no 5, so it's just 1. Okay, I wouldn't do an x, I wouldn't do a negative, so let's not do that. Okay, now the ABC comes from up above. So we're not going to place a number in front. There's no GCF. So positive 6 times positive 5 is positive 30. Okay, so that smells to me like negative, negative. And we're trying to add to get to negative 17. 1 and 30, divide, but that's negative 31. Divide by 2, you get 15, negative 17. Okay, now pay attention to your A. Your A is 6. So again, you can't go x minus 2x minus 15. You're going to use two sets of parentheses. And you're going to go 6x, 6x, and then minus 2 minus 15. So 6 and 2, 2 and 6. You're going to divide those by 2. That's 3x minus 1. 6 and 15, you're going to divide those by 3. That's going to be 2x minus 5. Okay, and those are your factors. 3x minus 1, 2x minus 5. Again, I don't need to put anything in the front because there wasn't a GCF. Again, so if you don't take notes on this, but if I made you multiply that out, it should wind up back here. I'm gonna it's like putting Humpty Dumpty back together again. So it's going to be 6 with x to the second. That's going to be negative 15 with x, negative 2 with x, and 5. So that's 6x to the second. If we add those, it's negative 17 plus 5, which is exactly what we started with. Okay, so that's it. There are no problems going on that. Now the other one, you're not solving these equations, okay? All these equations have an x to the second and an x not to the second somewhere. The only way to solve these is if you have it equal to 0, and that's what you're working on here. You're going to try to get the equation equal to 0, because right now it is not. So what you do is you put an implied 1 on any x that needs it. And then over here, you're going to put equals 0, and you're going to put blank x to the second plus blank x plus blank. Okay, now we want the 0 over here. So both these have to be removed. So it's negative, so I plus 8x. Now I look for just a regular x to plus that with. It would be with the negative 15. Then I also got the minus 10, so I plus 10. Now that's a constant, meaning it does not have an x. But it can't go in that column or that column, so I put it at the end. And now I clean things up. For x second, I got 1. For x, I take negative 15 plus 8. That would be negative 7. And then we have the 10. Okay, now that's good. I don't need you to solve it. Okay, next one, same idea. All these have an x to the second and a regular x. Well, that means you have to get one side of the equation equal to 0. Okay, so I want the 0 here, so I add 13x. Now that can't go in that column or that column, so I put it behind everything else. Minus 6. 6 is a constant, but it can go with the negative 8. So x second, I got 1. For x, I go to the 13. And then for the constant, I go negative 8 minus 6, negative 14. And now it's equal to 0. Now, if I had to solve it, I would use this stuff here, okay? But I do the F1, F2. Okay, now the next one, same idea. Put the 1 there. Again, let's get a 0 going there. So I need to add 12. Now, what column could I add 12? Not there, there. Oh, right there. So I rearrange everything. So x second, we got 1. X, you got 13. 24 plus 12 is 36. Okay, now the next one. Okay, so we want the 0 here, so we're going to subtract 18, but it can't go in that column or that column because 18 doesn't have x at all. It's a constant. Okay, put it at the end. So you got 1 for x second, you got negative 7 for x, you got negative 18. Remember, if it's got a minus in front of it, it's going to be a negative. Okay, really pretty easy, to be honest with you. Okay, let's get our 0. So I minus 28x. Now, that can't go in that column, so it goes behind everything. So I've got 14, and then negative 28. And then I don't have any constants, okay? So I delete that space, and it'd just be 2 terms. Okay, so we get that to 0 by adding 10x. And then that can't go with the 5x to the second, so I put it behind. If it doesn't have anything to go with, it goes like that. So you have negative 5, 10, and then you don't have any constants, so you would get rid of that. So if you had to solve it, you'd just go with the GCF Dobbs kind of deal. Remember, you're rewriting the equation so it's in solvable form. Okay, so plus 15 with the x, and that can't go in that because that's the x squared column. That's the constant column. So I put plus 15x right there. So x squared, you got negative 16. For x, you got 15, and then negative 1. Okay, so 9, we subtract 9. That can't go in the x squared or the x column, so I minus 9 there. So you got 8, 6, negative 9. Boom. Okay, pause the video and do that, and then come back for the last part. Okay, this is pretty easy here. The model of a jumbo jet's 230 feet long and has a 195-foot wingspan. The scale model is 40 centimeters long. How long is the model's wingspan? You're going to use ratios to solve this problem. And you're going to put 230 feet over 195 feet. Now, the 230 feet is the length. That's how long it is. And the 190 foot's the wingspan. It's like how a jet's wingspan is how far one wing, end of one wing is to the other. Okay, it's like a person's wingspan when they extend their arms. So you put WS. Okay, now 40 centimeters long. Okay, so 40 goes here, and we put X here. We line it up straight across. It's proportional, directly proportional, because the longer it is, okay, the longer the wingspan. So I take 195 times 40 and then divide by 230. Okay, round it to a whole number. It's going to be 34. So the wingspan's 34 centimeters, okay, because this is centimeters, so is that one. Okay, next one. Plane's 150 feet long, and it's got a 105-foot wingspan. That's the actual plane, okay? W span. Okay, now 6 inches long. Again, we're going to put 6 inches there, okay? And we need to figure out how many inches the wingspan is. So I cross multiply and divide. 6 times 105 divided by 150. I got 4.2. Okay, the model of a wingspan is 200 feet long. Okay, so 200 feet long, and its wingspan's 140 feet. So we got centimeters and centimeters. Now the centimeters they give me is how long it is, so it goes on top directly across. And I need to find the wingspan. So I take 140 times 25 divided by 200. 17.5. Okay, then finally, the model of the plane is 320 feet long, 250, so 320 feet long, 250 feet wingspan, WS. So again, 10 inches long. It's not the wingspan, so it's how long it is, so I put 10 here, X here. So 250 times 10 divided by 320 is 7.8. Okay. You can round however you want. Okay.